Problem 3. Infinite LC grid. When sine waves propagate in an infinite LC grid, see the figure, the phase of the AC voltage across two successive capacitors differs by phi. Question A. Determine how phi depends on omega, L and C. Omega is the angular frequency of the sine wave. Question B. Determine the velocity of propagation of the waves if the length of each unit is L. Question C. State under what conditions the propagation velocity of the waves is almost independent of omega. Determine the velocity. In this case, question D. Suggest a simple mechanical model which is an analog to the above circuit and derive equations which establish the validity of your model. Formulae: cosine alpha minus cosine beta equal -2 sine alpha plus beta over 2 multiplied by sine alpha minus beta over 2. Sine alpha minus sine beta equal 2 cosine alpha plus beta over 2 multiplied by sine alpha minus beta over 2. Question A. Determine how phi depends on omega, L and C. Omega is the angular frequency of the sine wave. Solution for problem 3. Question A. According to Kirchhoff current law we have equations 1. According to Kirchhoff voltage law we have equations 2. Capacitive voltage drops is in equations 3. Note, in equations 3 is used I tilde instead of I because the current leads the voltage by 90 degrees. Inductive voltage drops is in equations 4. Note, in equations 4 is used I tilde instead of I because the current lags behind the voltage by 90 degrees. The voltage VCN is given by formula 5. This formula follows from the problem. From equations 3 and 5 we have expression 6. From equations 4, 2, and using 5 we have expressions 7 and 8. Equations 6, 7, and 8 satisfy the current law. This gives the dependence of phi on omega, L and C. This condition must be true for any instant of time. Therefore it is possible to divide by V0 cosine omega t plus n phi. Hence omega square LC equal to 4 sin square phi over 2. And final result is 9. That was solution for question 1. Question B. Determine the velocity of propagation of the waves if the length of each unit is L. Solution of the second question. The signal transit time between adjacent capacitors is calculated by the phase difference phi divided by the angular frequency omega. So the distance L is covered in the time delta t, thus the propagation velocity is in expression 10. That was solution for question 2. Question C. State under what conditions the propagation velocity of the waves is almost independent of omega. Determine the velocity. In this case, solution of the question C. Slightly dependent means that this arc sine must be proportional to omega since speed v is constant in that case. This is true only for small values of omega. That means omega multiplied by square root from LC divided by 2 is much less than 1, and therefore V0 equal L over square root from LC. Expression 11. That was solution for question C. Question D. Suggest a simple mechanical model which is an analog to the above circuit and derive equations which establish the validity of your model. Solution for question D. The energy is conserved since only inductances and capacitances are involved. Using the terms of A, one obtains the capacitive energy in formula 12, and the inductive energy in formula 13. From this follows the standard form of the law of conservation of energy is formula 14. The relation to mechanics is not recognizable in this way since two different physical quantities Vcn and Cin are involved and there is nothing that corresponds to the relation between the locus x and the velocity v as first derivative of x. To produce an analogy to mechanics, the energy has to be described in terms of the charge Q, the current I as first derivative of Q, and the constants L and C. For this purpose the voltage VCN has to be expressed in terms of the charges QLN passing through the coil. One obtains, formula 15. However, QLN could equally be another quantity, for example an angle. L could be, for example, a moment of inertia. From the structure of the problems follows, interaction only with the nearest neighbor, the force rises linearly with the distance. A possible model could be next one. That was solution for question D. And here we finish discussion for problem 3.